Okay, so first off, we're gonna do some simplifying on radicals first, and then after we do some simplifying, then we're gonna move it into multiplication and division to do what we need to do. And here's the good thing we're going to do today. We're going to assume that variables are positive. And this is notes number 7. Okay, so we're going to do simplifying similar to what we did yesterday. The big thing is today we're going to assume that variables are positive, and that means if they're positive, we don't have to worry about absolute value. So those restrictions are off. You do not have to worry about putting absolute value on anything because we're going to assume that everything is positive. So that's just a little bit of help to kind of get us through this one so that there's less things we got to worry about when we focus on what we want to do. Okay, so here's what we're looking at. Yesterday, the bell ringer we're doing here was we were doing it so that the numbers were divided out evenly to get to this one. What happens if you divide 4 and 9? Does it go out evenly? No, right? Okay, so here's what we're going to do. We're still going to go ahead and think about this as being 9 over 4. And in that case, let's go ahead and just divide it. 4 will go into 9 2 times with 1 left over. All right, and if you can do third grade division, then you can do these variables because that's all you're going to do. You can divide those numbers. Now, here's the big thing. The top number you get here, this tells you how many exponents go outside. So this is your exit buddy. When we were doing exit buddies before, this is basically your exit buddies. This is how many of these you're going to get out. So now we're doing groups of 4. So 2 groups of 4 we get out. The number, your remainder, is what's going to remain on the inside because it is your remainder. So remaining exponent inside. Okay, so if they give you this one and they ask you what, if we do this part, what would the final answer be? We're going to have 2 x's that are going to go on the outside. So it's x squared. And we're going to have 1 x that's left on the inside. So it's going to be the 4th root of x to the first power. But again, if it's first power, you don't have to put that 1 there. We just have to know that there's an understood 1 that would be there. All right, now here's what the book will usually talk about doing and I don't like it as much because to me this one's a little bit easier because I'm just doing regular division. What the book will have you do, and you don't have to write this down. I'm gonna put this on like a side note because let me just, and again, if you want to write this down, you can. If you don't worry about it. Here's the book way. I don't like it the way the book does this sometimes. What the book says is they say, all right, if you've got the 4th root of x to the 9th, they say, if you do multiples of 4, what's the closest multiple of 4 to 9 without going over? That'd be 8, right? So you got 8 x's, you'd have 1 more left over, so basically you'd have that. And then they say, all right, go ahead and take the 4th root of x to the 8th. So go ahead and divide it by 4, and then you know that this part's going to be left over. So if you do the 4th root of x to the 8th, that's going to be 8 divided by 4, that's going to be x squared, and then you're still going to have that 1 that's left over there. It's the same thing. Yeah, it's the same thing, and that's fine until you get up to the numbers where you're doing and you've got x to the 67th. If you're doing the 4th root of x to the 67th, you start having to go through and think of the multiples, you're going to wind up just dividing it anyway. So it's like, okay, if we're going to divide it anyway to figure out what we're close to, let's just go ahead and divide it anyway. So now if you want to do it that way, that's fine. And for the smaller numbers, it works out. It's okay. It's just regrouping, rearranging numbers. But when the exponents start to get a little bit bigger, this seems to flow a little bit better. So, all right, so here we go. So let's do another here. So if that was example A, we'll mix it up a little bit. All right. So for example B, let's see if I can keep it in order today. Let's do the fifth root of y to the 17th. All right. And again, all you're doing is you're thinking, how many times will 5 go into 17? 3 times with 2 left over. And again, this tells you how many go outside. This tells you how many is left over on the inside. So we need y to the third on the outside. We need a y squared on the inside. And again, the only thing you have to be a little bit careful of when you're doing these, make sure that you leave your index there when you're doing that part. So whatever the index is that's here, you got to make sure that same index is going to stay there. Question? Oh, we're just dividing because basically, if you think about this one, this would be y to the 17 over 5. And you can think about just taking that back into like a mixed number. If you do that, that'd be y to the 3 2/5. So basically, in that part of it, whatever the whole number is, that part goes on the outside. And then whatever the fraction part that's left over, that's telling you how many need to be left over on the inside. Now, when you're doing these on Math Excel, there actually is a button that has a root and it has a box here and then a box here. And that way you can go back in and it will tab over. You can put in a number here, you can tab over to put a number there. So with Math Excel, there's actually a box button that's got these two radicals here with a box here and a box here. So that way you can put in the fifth root of y squared on that part. Yes, so whatever your index is to start with, when you simplify it, it will stay the same.
So I think C last time. Well, okay, so we have here 1/2.
Okay, we're right in the middle of lesson. So. All right, so let's do the sixth root of y to the 23rd. All right, and again, if you're just, and some of these, and we're actually kind of previewing some things that's going to happen in a little bit, because some of these, they're going to ask you to change it from radical form to exponential form, which is really what we're doing. So that could be y to the 23rd over 6. So now we're going to divide 6 into 23. So that'll go 3 times with 5 left over. Oh, okay. Okay, and again, you can think about it a couple of different ways, but basically, here's what we're going to do, because we're going to do multiple variables with this one. Whatever comes here, this tells you, this is your exit buddies. This is telling you how many get out of the radical. Your remainder tells you how many are going to remain inside the radical. So you're going to have 3 y's that get out, but you're going to have 5 y's that's going to stay in. So you're going to have y to the third on the outside and 5 y's that will stay on the inside. And because this was index was 6 here, that index has to stay the same there. Okay. Everybody all right there so far? Everybody feeling okay? We're going to spin off of it a little bit. Yeah, we'll keep coming back to it. All right. How about one more by yourself? Let's go with the 7th root of. You want to do 2 variables or just 1? Let's try 2. Okay. Let's go with x to the 30th and y to the 15th. Okay, so two variables. Basically, it's like a two-part answer. You do the x part, and then you do the y part, and then you put them back together.
I'm sorry to interrupt your class, but do you have any, just like one more minute?
Okay.
I think I got it actually. It's too big. I don't like how it looks. I think I just put it on. Do what things are. Is that what you did?
Yeah, it's kind of crazy.
It looks right. It looks confusing.
Just read it wet. So if we like, something like this.
Okay, so for x, it's 30 over 7. Y, it's 15 over 7. So we're going to take 7, divide it into 30, which will go 4 times with 2 left over. 7 to go into 15, 2 times with 1 left over. All right, now here's kind of the reason why I like to do these this way, not the way the book does it. If you set these up as division problem, if you have it kind of rewritten where it's like in this exponential form, when you do these, you know that these are the numbers that are going on the outside. Both of these, both of the remainders are what's going to be left over on the inside. So on the outside, you're going to have x to the 4th, you're going to have y squared, and then on the inside, you're going to have x squared and y to the 1st, and then don't forget the 7. Okay.
And I'm just like, why did I? Because it doesn't make any sense. No, but like, I know because I even went.
All right, everybody. Anybody feeling lost at this point? Everybody okay? All right. Okay, so if you're feeling good about that one, let's expand it just a little bit, and let's talk about that now. Instead of just having a number here and we're going to simplify it, we're still going to do the same thing, but we're going to have to do something first. We're going to have to multiply first. Yep, we're going to multiply the radicals. All right, step 1. Now, step 1's more, I wouldn't even really call it a step. It's more like a check. So this would almost be like a check before you do your steps. Because if you get this part, so this, and again, really should call this check and not step 1. But anyway, we'll do it this way. The indexes, or if we're looking at the two different radicals, the index must be the same. If the index is not the same, you cannot multiply. You cannot add, you cannot subtract, you cannot divide. So before you can do any operation with radicals, the index has to be the same in both radicals that you're talking about. So if the index isn't the same, you just skip it and go on. Nothing else you can do to it. All right, second thing is, once you've got that, you're going to multiply the radicands. And then the other thing you're going to multiply is, okay, and if you're going back to these, your radicand is on the inside. And you may have a coefficient out front, so we'll just call that coefficients out here. And multiply your coefficients if there are any. So you got your coefficient in front, you've got your radicand here. Again, technically your index would be right there. Okay, so basically you're multiplying your inside numbers. You're going to multiply your outside numbers. And then after you've done all that, you simplify if possible. And when you're simplifying, you're going to be simplifying the radicand's what's on the inside. And in most cases, I would say 99, 95% of the time, there might be one question along the way here or there where you're not able to simplify, but almost every question that you do, you're going to probably be able to simplify just a little bit. All right, just keep everybody on the toes. We're going to do example 1 this time.
So unpredictable.
All right, so let's go third root of 18 times third root of 3. All right, again, step 1, you're checking the indexes or indices. Man, how you say it there. Index square root of 3 in both of these, so we're good to go. So we're good on that part. So now we're going to multiply what's on the inside. And here's where I would say go ahead and multiply those two numbers together and see what you get. There are no coefficients. There's nothing on the outside, so we don't have to worry about step 3. Now we're just going to simplify this one. And here's where, depending on which calculator you have, you punch it in. We're going to check third root of 54. I would go ahead and do 3 third root of 54 and just see if you happen to get lucky and you get a perfect radical. In that case, we don't, which means we've got to break it down. We've got to simplify. If you get this number and you check it and it's a decimal number, it means it's not a perfect radical. It means you've got to take this thing and you've got to break it down. Now, before you try to freak out on this one, especially when the numbers are big, and it's like if you multiply together, it's like 724. And you're like, how am I going to do that? You did 18 times 3 to get 54, right? So let's just break it down as 18 times 3 because that's the two numbers we use to multiply. So, yeah, so just go ahead and break it down that way. Now we can do this as 2 times 9. That would be 3 times 3. Okay, so if you take it and break it down, that's 2 times 3 times 3 times 3, right? Everybody okay with breaking down to 54? Everybody all right with it being those numbers?
Can we use the ladder method?
You can absolutely use ladder method because if you do 54, it would be, again, 3 out here, 18 here. 3 times 6 would be that. You could do 3 times 2. So there's 3 times 3 times 3 times 2. All right, and then this is where you get to use your exit buddies. It's to the third power, so you're looking for 3 of a kind. 3 of a kind right there, right? So that 3 gets out. That one doesn't have 3 of a kind, so it stays on the inside. And that's going to be your final answer.
That was too much work for such a simple answer.
Okay. So you're going to have to multiply things together, and then you're going to have to take the number and break it down. And again, the simplifying part is 99% of everything you do, you're going to have to simplify something along the way.
Wait, so if it's to the third, it's gonna look for.
So let's go, for this one, let's do square root. Let's do the square root of 8x to the 5th times the square root of 3x. All right, so let's go ahead and put it all together because there is, again, no coefficients on the outside. So we're doing 8 times 3 for 24. And remember with the exponents, you're going to do x to the 5th times x to the 1st. So that would be the square root of 24, x to the 6th. Yes, so the index in that case would be 2, yes. So no index there, so we're knowing that index is going to be 2. Okay. All right, and then break it apart because now square root of 24 is not a perfect square root, so we're going to have to break it down. So you can think about this one in two parts. It's square root of 24, and it's square root of x to the 6th. So we take 24 and start to break it down. Again, I'm going to go ladder method just because I like the ladder method better. It's 2 times 12 to get 24. That's 2 times 6, which is 2 times 3. If you want to go, factor tree, you could do 3 times 8 because we already had 8 times 3 there. That would have been 2 times 4, which would have been 2 times 2. So either way you go, you get 2 times 2 times 2 times 3. Question?
Wait, so where is the exponent of 2 from? That's on the outside.
Oh, if there is no index here, it's always understood to be a 2. Okay. All right, so with the 24, that's 2 times 2 times 2 times 3. And with x to the 6, we're just going to take 6 and divide it by 2. All right, pair of 2's. So the 2 will get out. These don't have any exit buddies, so they stay on the inside. So go ahead and do 2 times 3 and make it 6. Okay there? May, you all right?
No, I just have one quick question.
Sure.
Because I forgot how to do this. With the 2 on the last one.
Okay, and then this one works out nicely because 6 divided by 2 is 3, right? So if you divide 2 into 6, it'll go 3 times with no left over. So we know there's 3 x's that's going out. There are no x's left over on the inside, so it's just x to the third. So now that was just a matter of cleaning this up. This x to the third is on the outside. So really this answer is 2x to the third squared root of 6.
Do we have to put 2?
The index here? No, if it's square root, you do not have to put the index of 2. All right, let's do the third root of 4 x to the 5th y times third root of 6x squared y to the 4th.
Whoa, you write really fast.
Okay.
Yeah, you do.
Oh, well, thank you.
Fast.
I've had 48 years of practicing. Yeah, can't remember how old I am. All right, and again, very first thing is the index here must be the same as index here. If those indexes are different, you can't do anything with it. It would just stay that would be the answer. That would be it. But in this case, they're both third root, so we're okay. So basically, put it all together. We're going to do 4 times 6, which is 24. For the x's, you got 5 here, 2 here. Add those together, make it x to the 7th. Technically, that's y to the 1st. So for the y's, it's 1 plus 4 to make it y to the 5th. Okay, so we're going to take one step at a time and check, make sure everybody okay with where we got those numbers. Yes, I will let you write that down. Okay, I wish we had like green and red light buzzers and everybody flip on greens when they're good to go. And then all right, so if you're good putting it together, again, check. If you check third root of 24, just to be on the safe side, it is not a perfect cubed number because we need, 2 times 2 times 2 would be 8, 3 times 3 times 3 would be 27. So we just missed it by a little bit that one. So it is not a perfect number. So think about this one in parts. We're going to do the third root of 24. We're going to do the third root of x to the 7th. And we're going to do the third root of y to the 5th. All right, and with 24, you can either go stack method or the stack ladder method. You can go with your factor trees, ever how you want to do it. I'm going to go ahead and go ladder method just because I like the ladder method better. 24 divided by 2 is 12. 12 divided by 2 is 6. 6 divided by 2 is 3.
Wait, pause.
Okay.
So for this one, you can do the 3. Yeah,
Mhm.
you're looking for 3.
Yeah, so it's third index is 3, so we're looking for 3 of a kind. So if we stack all these numbers we've got here, down here. All right, again, that seems to be the overriding question that we keep popping into. How you know what you're looking for is the index. So whatever the index is, that tells you how many of a kind you're looking for. So if the index is 3, you're looking for 3 of a kind. You're looking for groups of 3. And there's our group of 3 right here. We've got 3 2s, so we know that 2 will come out. This 3 doesn't have any other 3s to go with it, so it's going to stay stuck on the inside. So if we were breaking down, if all we had to do was break down the third root of 24, that answer would be 2 times the third root of 3. And then we're going to do each of the variables one at a time. And here's why I like the variables doing what we're doing. In this case, that's x to the 7 thirds, which means we're going to divide 3 into 7. And again, this is third grade math. 3 going to 7 2 times with 1 left over. Good. And then do the same thing with the y's. That's y to the 5 thirds, which means we're going to do 3 into 5. So 3 going to 5 one time with 2 left over. All right, again, here's why I like dividing it this way, not the book way. Because whatever you divide with these two, this tells you how many get out. This is your groups of 3. So there's 2 groups of 3 x's. There's 1 group of 3 y's. So this tells you how many gets out. These are your leftovers. These are your remainders. So these are going to remain on the inside of the radical. So for this one, the x is going to get, you're going to have x squared on the outside. And you're going to have 1x on the inside. Again, still index of 3. And for this one, you're going to get 1y on the outside, and you're going to have 2 y's on the inside. So again, we'll just kind of take it, one little piece down. So the x's would have that. So we had the third root of x to the 7th. We've got 3 going to 7 2 times with 1 left over, so that's the 1 that's left over here. If we did the y part of it, 3 going to 5 1 time with 2 left over, so there's the 1 that goes out, there's the 2 that's left in. Okay, and once you've done each little bitty piece, now you got to put them all back together. Take everything that's on the outside and put it on the outside. So it's going to be 2 x squared y on the outside, because all those are on the outside. And then on the inside, you've got a 3, you've got an x, and you've got y squared.
This is very, I feel like doing the whole problem is very ugly, but like, I don't think
It's just, yeah, little piece at a time. Yeah, little piece at a time as you go through those. All right, one more multiplication problem.
Okay.
Make the numbers a little bit bigger. And for this one, we'll go with square root. We're going to go 45 x to the 5th, y to the 3rd times 35 x, y to the 4th.
Ew. Oh, no.
Okay, so 45 times 35, x to the 5th, x to the 1st, y to the 3rd, y to the 4th.
Okay, can we have a second to write it?
Sure.
I don't understand how you write so fast. G.
Many years of practice.
All right, and I do not know 45 times 35 off the top of my head, so I checked on the calculator. It's 1575.
25. And then add that to, well,
Okay, so 1,575.
I did it.
We've got x to the 6 because we're adding 5 plus 1 on the exponents there, and then 3 plus 4 to make it y to the 7. All right, and more than likely, that is not going to be a perfect square root because it would just not be great if it worked out that way. No, getting close. Need it to be 1,600. That would have been 40 times 40, but we're not there. All right, now this one, I would not do the stack method on this one or the ladder method because it's going to be a while. Because if we take 1575 and start to break it down, I would go ahead and break it down as 45 times 35 because that's the two numbers we multiplied to get there. And I can work with that because those numbers are a lot smaller than 1575. All right, that's 5 times 9. That's 5 times 7. That's 3 times 3.
Yeah, so you can't do. How many do you need to have?
Need all the prime numbers that will go into it.
I forget prime numbers.
So 3, mainly 2s, 3s, 5s, and 7s, but it started off with the odd numbers, so mostly we're staying with the odd numbers there.
Okay. That's not that bad.
All right, so we got 3, 3, 5, 5, 7. Okay, and again, you're probably thinking with 1,575, it's going to be huge. It's really not that bad. Because again, its index is 2 because it's square. We got a pair of 3s, so the 3 will get out. A pair of 5s. The 5 gets out. The 7 does not have a pair, so it will stay on the inside. And I'll scroll it back up here in a minute. So that is 15 square root of 7. Oh, we took 9 to make it 3 times 3.
What? Huh?
Because we had the pair of 3s on the outside, pair of 5 on the outside. We did 3 times 5 on the outside to make it 15.
Oh wait, my brain is just
All right, now we still got the variables. Up here, we've got x to the square root of x to the 6th. We've got the square root of y to the 7th. And again, because it's square root, we're basically taking x to the 6th and dividing it by 2. We're taking y to the 7th and dividing it by 2. But the good news is, what is 6 divided by 2? 3. No leftovers, correct?
Yep.
So we don't have to worry about anything on the outside. For the y part of it, for this part, we're dividing 2 into 7. Goes 3 times with 1 left over. So for the y's, we know there's going to be 3 on the outside and 1 on the inside. So we need y to the 3rd on the outside, and we need y to the 1st on the inside. Okay. And we still had to get about the x to the 3rd that was here. And then we put it all together. So on the outside, we've got a 15. We've got an x to the 3rd and a y to the 3rd. So on the outside, we've got 15, x to the 3rd, y to the 3rd. And then on the inside, we've got this 7 and this y. And then there's your final answer.